All right, last topic in this unit, 1.7 part 2, I can solve and graph absolute value inequalities. So when we were working on this previously, we were solving absolute value equations. Now we're going to be solving absolute value inequalities. Now this should be no problem at all as long as we remember how we solve inequalities. So you've probably, if you've been listening to me or heard me teach before, you've probably heard this. We solve inequalities just like we solve equations. So there really aren't any other techniques that we need to learn. We just need to keep track of two things. We solve them just like we solve equations, except when we multiply or divide by a negative. Remember, when you put a negative in there, you're introducing this idea of an opposite. So what we have to do is we have to switch the direction of the inequality. Inequality, okay? All right, so let's take a look at this example right here. Now, this is an absolute value inequality. If this was an equals, it's already isolated. We break it into the two cases and all that sort of stuff. So what I want you to remember is, what does absolute value mean? Absolute value refers to distance from zero. So I'm going to write distance from zero. Distance from zero. So what this means is the distance that x is from 0 has to be less than 5. The distance that it is from 0 has to be less than 5. So if 0 is right here, that means it can't go any more than 5 units this direction. So we'll put a 5 right here. And it can't go any more than 5 units in the other direction. So it can go down up to here and down to there. So what it means is we're this stuff in between here. Notice that it's a strict inequality. It's less than. So we can't go right up to 5, but we can't hit 5, but we can go right up to it. And we can't hit -5, but we can go right down to it. Anything in here. So if we did a 1, 1 is definitely less than 5 units away from, less than 5 units away from 0. If we did -3 right here, -3 is only 3 units away from 0, so that's definitely less than 5 units from 0. Okay, so that means that our answers are bigger than -5, and at the same time they are less than 5. So that would be one way that we could write that down and think about it. We could also write that, because it's the word and, we could write that compound inequality without using the word and. You might want to think about how to do that. And then on this one right here, this one is already isolated. So it means the distance that this is from 0 has to be bigger than 6. So if 0 is right here, 6 would be over here, and that means, so it could be there and further, so 3x could be on this side of that. And then going the other way, we could be more than 6 units going the other direction. So that would be down here, and 3x would be over there. So we'd have to do a little bit of solving here. So let me solve this one. Those didn't need any solving. So that means that 3x has to be smaller than -6. Okay, smaller than or equal to -6. And then this one right here, 3x has to be bigger than or equal to +6. And then we'd solve each one of those. So we're going to divide by 3. Let's see, so this is -2. Yep. And then on this one right here, we're going to divide by 3. So this is going to be 2, and x is there. And if I wanted to, I could kind of flip those around. And because it comes in 2 pieces, we'd have to have an or. Now, these are the essentials of what's going on here, but this is really kind of a hassle to keep a number line on this. This is really kind of crazy. So what's going to be really helpful is if we can say, hey, look, if it's a less than, I'm going to do it this way, and I get 1 piece, and if it's a greater than, then I'm going to do it this way, and I'm going to get 2 pieces and stuff like that. So in order to solve these the right way, so here's what we're going to do. A less than means and. A less than is like this one. It's in between the two of these. It's got to be less than this, and it's got to be bigger than that at the same time. A greater than means or. So it's got to be less than this one right here, or it could also be bigger than that one right there. Now, don't forget that these only work when the absolute value is on the left side, like we had here. We had it isolated over here. So the first thing we're going to do, again, is isolate the absolute value first, just like we did before. We're going to break it into the two cases. Remove the absolute value and solve the inequality. Remove the absolute value and make the number on the opposite side the negative of what it was. and I'm going to show you something that we need to do right there. And then we solve each case. And remember, you've got to know if you've got to have an and or an or between those. Then we're going to graph the final solution and the answers. So let me show you how to do this problem right here. So on example 7a, this is what we do. So we're going to subtract 5 to isolate. We're going to get absolute value of x minus 4. And then this is a less than or equal to, and this ends up being a 5. Now we've got this isolated. So we're going to remove the absolute value. So I'm going to break it into these two cases right here. So I'm going to do x minus 4 less than or equal to 5. And then the other one is remove the absolute value and make the number the opposite of what it was. So this is going to be x minus 4. This is going to be a negative 5. And here's where the key is. This is where this is a little bit different. Remember, if we introduce a negative into an inequality, we've got to switch the direction of the inequality because we're introducing the idea of an opposite. So remember to switch the direction of the inequality. So this used to be a less than. We're now going to make this a greater than. Okay? All right, so this is also a less than. So remember, the word less than is an and. So I'm going to write the word and between these. So that's going to be an intersection. That's going to be where these overlap. This is going to be both types of shading. Now, I realize I'm going fairly quickly. We are going to do several examples. So I'm hoping by the time we're done with these, we've kind of got this dialed in and we're in good shape. So let me go ahead and solve this one. This is going to be, we're going to add 4. So this is going to be x is greater than or equal to, this would be negative 1. And at the same time, let's go ahead and solve this. So we're add 4. So this would be x is less than or equal to 9. So negative 1 would be right here. We're going to shade that in, and it's going to be greater than that. And then we've got x is less than or equal to 9. So 9 is going to be right here. So we're going to fill that in, and it's got to be less than that. So this shading goes that way, this shading goes this way, so it's going to be everything that has both types of shading, so it's going to be everything in between. So I'm going to clean this up just a little bit. It's all of this stuff right here, okay? So this is how we solve it. We could write it like this. There's an inequality that works for that. There's the graph of this. And you'll notice in the instructions it says write the answer in interval notation. So if we were to write this in inequality notation, the answers would be bigger than negative 1. So the x's are greater than negative 1 and they're less than 9. That's totally okay. But the easiest way to answer this is just write it in interval notation. Again, start on the left end. We don't get any answers until negative 1. So this would be from negative 1 all the way up to 9. And because both of those are included, we're going to use square brackets on that. So that right there is the answer. So we've got it as an inequality, we've got it as a graph, and we've got interval notation. So we've solved the inequality, we've graphed the solution, and we wrote the answer in interval notation. So there we go. Now I'm going to switch colors for this next one. We're going to go ahead and isolate. So we're going to subtract 2. Got to do that first. So then we have the absolute value of 3x minus 3. And then this is a greater than or equal to, and this is going to be a 13. And I'm going to go ahead and zoom in here so we've got a little bit more space to work with this. So let's see here. It is isolated, so we're going to break it into the two cases. Remove the absolute value. Leave everything just the same. On this one here, remove the absolute value and make the number the opposite of what it used to be. And remember, when you make the number the opposite of what it used to be, you have to change the direction of the inequality. And when it's a greater than, the word that connects these is an or. So let's go through and solve this. So we're going to add 3. So this is 3x less than or equal to negative 10. So this is going to be x is less than or equal to negative 10 thirds. And over here, we're going to add 3. So this is 3x greater than 16. So this is going to be x is greater than or equal to 16 thirds, because we just divide both sides by 3, just like we did here. Okay. All right. And the word that connects these is or. Okay. So this would be the answer as far as if we were writing them as an inequality. The word that connects these is or, so anything that's shaded is going to be totally okay. So negative 10 thirds. So I'm going to put 0 right here, and I'm going to circle this. Let's write that as negative 10 thirds. And the answers are less than that, so they go this way. They're further out from 0. And 16/3, I'm going to put a circle right here and call that 16/3. And we'd shade that in. And the answers are bigger than that right there, so they shade this direction right here. Now, perfectly okay to write the answers in inequality, perfectly okay to graph it. It did ask us to do that, but we want to make sure that we write the answer in interval notation. So starting from the left, we start getting answers at negative infinity. We stop at negative 10/3. That's included, so we're going to use a square bracket around the negative 10/3 and a open bracket, a round bracket around negative infinity. Then we start up. We've got another piece, so we want to union these together. And these answers start up again at 16/3, and they never stop, so they go all the way to positive infinity. And this right here is really the answer that we want. Okay, it's probably the easiest way to write the answer. So I'm going to go ahead and draw a line here, slide over, and let's take a look at this next one. Already isolated, and we've seen some stuff like this before. So here's what we're going to do. Break that into two pieces, 3 minus 5x over 6 less than negative 3. And this one, we just write it down without the absolute value. So this is going to be greater than 3. Now remember, if this is a greater than, the word that connects those is an or. So either this is true or this is true. If it's an and, they both have to be true, and that's why we're looking for an overlap. So on this one, we're going to have 3 minus 5x. We're multiplying by 6, so that doesn't change the direction of the inequality. We're going to move that to the other side. We're going to do that by subtracting 3, so negative 5x less than, this is a negative 21, divide by negative 5. So we do have to change the direction on this one. This is going to be greater than 21/5, so there's one of them. And we've got an or here, and then let's solve this guy right here. So this is going to be, whoops, this should be a 6, shouldn't it? So we'll multiply here, so this is going to be 3 minus 5x greater than 18. Subtract 3, negative 5x greater than, this is going to be a 15. And we're going to divide by negative 5, so we have to switch the direction. I'm going to slide this over so it looks a little bit better. This is going to be a less than negative 3. Let me make sure I got that right. So cancel those off. 15 divided by negative 5 is negative 3. So I think we're in good shape. Okay, so there is the inequality. So now let's graph this. Bigger than 21/5, so that's a little bit bigger than 4, and less than negative 3. So we're going to do this. 0 here, negative 3 here. Open circle on each one of them. 21/5, we'll put that about right here. And bigger than 21/5, we're shaded this way. Less than negative 3, so we're shaded this way. And the word is or, so it's either here, or if it happened to have both types of shading, then we'd include that. But there's a graph of the answer. Now let's write it down in interval notation. So again, starting from left, going to the right, the answers start way down there at negative infinity. They stop at negative 3, always round around infinity, but negative 3, it's an open circle, so that's going to not be included either. Union, because we've got this other piece that starts up at 21/5 and goes all the way to positive infinity, and then we close that off. So that right there is really what we're looking for here. Okay, so that's how we do these. And then there are some other inequalities that I want to take a look at that have some interesting answers, but I want you to think about these. Might make it easier. You can always break it into these two cases. These are a little bit tedious. They do take some practice, and you've got to spend some time. But if you're good at solving the inequalities, you should be in good shape here. Or sorry, solving the absolute value equations, you should be good at solving the inequalities. So let's take a look at this one. This one says, same instructions, solve the inequality graph and then write the answer in interval notation. So notice that this is already isolated. So if we were to try and break this up, here's what we get. X plus 4 is greater than or equal to negative 0. Well, there really is no negative 0, so we can just put it like that. Okay. And then on this one, this would be x plus 4 is less than or equal to 0. Okay. Now, stop and think about this. What this means is the distance this is has to be less than or equal to 0. Well, that's that 0 case, so this is interesting. Let's go ahead and solve this. This is going to be negative 4. So this is going to be x is greater than or equal to negative 4. This is going to be subtract 4. So this is going to be x is less than or equal to negative 4. So here's what we've got. And the word that connects this is a less than, so this is an and. So here's 0 and here's negative 4. And what we're saying is these answers say it's bigger than negative 4 or equal to negative 4. And these answers say it's less than or equal to negative 4, so shading that way. So it has to have both types of shading. So the only place where it has both types of shading was right here. Okay, so the answer on this one is x equals negative 4, which if you stop and think about it, if you plug in a negative 4, that's the only time where this is going to equal 0. So hopefully that makes sense. Again, some of these are a little bit weird. Okay, and again, let me fill this in. The key to remembering, the key to doing these problems is remembering that absolute values refers to distance, and distance is always positive. Okay, so the smallest an absolute value could possibly be would be 0, and in that case, we only get one answer. Now on this one, this is saying that this is greater than or equal to negative. So this is always positive. And it's saying that's greater than or equal to a negative. We'll stop and think about that for just a second. And this one is very similar. This is saying that a positive is less than a negative. So let's think about this one. This one says a positive is always greater than or equal to a negative. Well, positives are always greater than negatives. So this one would be all real numbers. Okay, or all numbers. If we were to graph that, it would be everything from one end of the number line to the other end of the number line, okay? And in interval notation, that would be everything from negative infinity to infinity, okay? So any number you plug in there is going to make sure that this is positive, or at the very least 0, and that's always going to be greater than or equal to a negative. And then this one right here is kind of the opposite case. When is a positive less than a negative? Well, that's just never going to happen. So on this one, it is no solution. Okay, now it is possible to go through and solve these using these techniques of breaking these apart and stuff like that. It's just a lot quicker if you can kind of reason your way to the answer. Now, I do want to point this out. You do need to rate yourself on how well you understand this. You may be a little bit shaky on this. This is one of those topics that takes a little more practice than some of the other ones. So make sure you give it the correct amount of time. And then there's a thought experiment here. You can do every single one of them this way. This whole idea of breaking it into two cases, figuring it out that if it's a less than, it's an and, if it's a greater than, it's an or, and doing it that way, that's totally okay. There is a shortcut for the ones that have less thans. So if they have less thans, there is a shortcut. It's not a great shortcut, but it does work. And it all comes down to these guys right here. So if it's a less than, stop and think about what that word means. And is it possible to write an inequality that doesn't have a word or a symbol in it? So I am going to go ahead and pull up one problem on the assignment, and we're going to go ahead and do that one. Okay, I've pulled up the assignment. This is problem number 7. It's on the back side. The instructions are the same. We're supposed to solve this, graph the answer, and then write the answer in interval notation. So let's go ahead and take a look at this problem here. You'll notice that it's not isolated right now, so we do need to isolate it. So I'm going to go ahead and subtract 3. So this is going to be absolute 8a minus 3 less than 67. This is a less than, so when I break this into two cases, the word that connects the two of these is going to be an and. So on this one over here, when we're going to the right, again, we just take off the absolute value. We solve it like we normally would any other inequality. And then over here, what we do is we take off the absolute value and we make the 67 negative. And remember, when we introduce a negative into an inequality, we have to switch the direction of the inequality. So I want to find when this is true and at the same time when that's true. So let's go ahead and solve. So I am going to add 3. That's going to give me 8a is greater than, this is going to be a negative 64. We're going to divide by 8. So this is a is greater than negative 8. So we've got this guy right here. And this one has to be true over here. So I'm going to add 3. So that's going to be 8a. Less than 70, and we're going to divide by 8. So I'm going to get a is less than, And what we get here is I need to reduce this. 4 doesn't go into 70, so 2 is the best we can get. So this is going to be, whoops, 35 over 4, okay? So we need to do the 2 of those. Now, we've gone ahead and we've solved it, so technically that's a perfectly good answer. Now we want to graph this. So again, I'm just going to kind of sketch things out here. I'm going to put 0 about right here. -8 we'll put about right here. And 4 goes in here 8 times and a little bit more. So that's going to be over here at 35/4. Now, on this one, it says the answers are greater than -8. So I'm just going to shade this direction right here. And remember, this is not filled in. It's not equal to, so we don't fill that in. And then this one right here says the answers are less than 35/4. So that means we'd shade over this direction. So we do have some overlapping shading. This one's going to continue going off in this direction. That one's going to continue going over there. But and means both. We need both types of shading. It's the overlap. So we want the overlap here. Well, the overlap is just from here to here. So I'm going to go ahead and erase this, and that's why it's kind of nice to do that a little bit light the first time you do it. What we want is this answer right here. So I'm just going to shade in here. That would be the overlap. So there's our graph of the inequality. Now let's write it down in interval notation. And again, this is just awesome because once we've got this graph, we start over here on the left and we say, look, we don't get any answers until we get to -8. So they're going to start at -8. We put a comma, and they're going to stop at 35/4. Now, neither one of those are included, so we put round brackets around each one of those to indicate that they would be open endpoints. And there we go. If you can do that on a test, you're in great shape. All right, good luck with the assignment.